Imagine stepping off a spacecraft onto the planet scientists once believed could be humanity's second home, almost the same size as Earth, almost the same gravity holding your feet to the ground. A rocky world circling the same star, close enough that early astronomers imagined oceans hiding beneath its clouds, maybe even jungles, maybe even life. You take your first breath of recycled air inside your suit, look out at a hazy golden sky, and prepare to take humanity's next great step. You wouldn't get the chance, because within minutes, before you could even process what was happening around you, everything about this planet would already be working to destroy you. Not one danger, not a single threat you could prepare for and overcome. Every single element of this world, the air, the sky, the ground, the light itself, is hostile in a way almost nothing else in our solar system can match. And here's the detail that surprises almost everyone who hears this story for the first time. This isn't the planet closest to the Sun. Mercury holds that position, but Mercury isn't the hottest world orbiting our star. This one is, hotter than anything sitting nearer to the fire at the center of our solar system. This is Venus. And by the end of this journey, you'll understand exactly why every mission we've ever sent there has struggled simply to survive, and why scientists keep sending more anyway. If stories like this pull you in, subscribe to Beyond Cosmos, because we explore the strangest, most extreme corners of our universe every single week. Now, let's step onto the surface of Earth's evil twin. For a long time, Venus carried a kind of hopeful mystery. Its diameter measures about 95% of Earth's. Its gravity sits at roughly 90% of what you feel standing here right now. Its internal structure, layered rock wrapped around a molten core, closely resembles our own planet's design. From a distance, wrapped in thick, pale clouds that hid its surface from every telescope pointed toward it, Venus looked less like a threat and more like a promise. Early scientists speculated about oceans stretching beneath that cloud cover. Some imagined dense jungles, humid and alive, hidden just out of sight. It made sense, in a way. Two planets, born from the same cloud of dust and gas, nearly identical in size, positioned relatively close together around the same star. If Earth turned out lush and blue, why couldn't Venus have followed a similar path? Then humanity actually looked closer, and what those clouds had been hiding wasn't a paradise. It was one of the most punishing environments any planet in our solar system has ever produced. Here's where the story takes its first sharp turn. Ask anyone which planet in our solar system is the hottest, and most people will say Mercury without hesitation. It makes intuitive sense. Mercury sits closest to the Sun, scorched directly by starlight with almost no atmosphere to soften the blow. But Mercury isn't the hottest planet. Venus is. Venus's surface temperature sits at roughly 467 degrees Celsius. That's close to 870 degrees Fahrenheit. To put that number somewhere your imagination can actually hold it, that's hot enough to melt lead into liquid on the ground beneath your feet. Mercury, despite its brutal proximity to the Sun, actually has wide temperature swings and cooler averages because it has almost no atmosphere to trap heat once the Sun isn't directly overhead. Venus's secret weapon isn't its position, it's its atmosphere. Wrapped around Venus is an incredibly thick blanket of carbon dioxide, so effective at trapping heat that almost none of it ever escapes back into space. Scientists call this a runaway greenhouse effect, and it's the reason the closest planet to the Sun isn't actually the hottest world in our cosmic neighborhood. The atmosphere decides the winner, not distance, not sunlight. The air itself became a trap, absorbing heat, holding it, compounding it year after year until the entire planet turned into something closer to an oven than a world. But that wasn't the worst part. Heat alone might be survivable with enough engineering, enough insulation, enough clever technology standing between a human body and the outside world. Pressure is a different problem entirely. At Venus's surface, atmospheric pressure reaches roughly 93 times what you experience standing at sea level on Earth right now. Numbers like that are difficult to feel, so here's a comparison that makes it real. Standing on Venus's surface would feel physically like being crushed under nearly 900 meters of ocean water back on Earth. Not a swimming pool, not a lake, nearly a kilometer of ocean pressing down on every square inch of your body simultaneously. A human being wouldn't simply suffocate under those conditions. The environment itself would relentlessly crush anything not specifically engineered to withstand forces like that, equipment included. Metal casings built for far gentler conditions elsewhere in the solar system have failed under exactly this kind of relentless compression. This isn't a threat you outrun or shelter from temporarily. It's constant, total, and unforgiving from the moment you'd arrive. And if the heat and the pressure weren't enough, look up. Venus's clouds aren't made of water vapor drifting harmlessly overhead the way clouds do on Earth. They're composed primarily of sulfuric acid droplets suspended high above the surface. It sounds like something out of a nightmare, and in some ways it is. But here's where scientists ask for precision instead of exaggeration. Most of that acid actually evaporates before it ever reaches the ground, broken down by the extreme heat during its descent. So it isn't quite accurate to imagine acid rain constantly drenching the surface below. What is accurate, and still deeply hostile, is that the cloud layers themselves remain highly corrosive, chemically hostile to nearly every conventional material humans have ever built spacecraft from. Any mission attempting to pass through those clouds has to survive an atmosphere actively working to dissolve it, long before it even reaches the crushing heat and pressure waiting below. Heat that melts lead, pressure equivalent to the deep ocean, clouds built from corrosive acid, and still, humanity tried to land there. Here's where the story becomes almost unbelievable. Decades ago, the Soviet Union accomplished something no other nation has matched since. Through their Venera program, they successfully landed spacecraft directly onto Venus's surface. Venera 7 became the first spacecraft in history to achieve a successful soft landing on another planet, transmitting data back from a world everyone knew would eventually destroy it. Years later, Venera 13 went even further, capturing color images of the Venusian surface and continuing to operate for approximately 127 minutes before succumbing to the environment around it. Other landers in the program weren't as fortunate, surviving for as little as 23 minutes before falling silent forever. Here's what makes this even more remarkable. These spacecraft weren't destroyed in a single dramatic event. No explosion, no sudden catastrophic failure captured in one terrifying instant. They simply, slowly succumbed. The heat crept in past their insulation. The pressure gradually overwhelmed their reinforced hulls. Engineers back on Earth watched their creations survive minute by minute, knowing precisely how the story would end, and still counting every additional second as a victory. Think about that kind of engineering challenge for a moment. Building something specifically designed with a countdown to its own destruction already built into its expectations, not hoping for survival, simply hoping to last long enough to send home whatever data it could gather before the planet finally won. You'd think, after results like that, humanity would simply stay away. Instead, the opposite happened. NASA is currently preparing new missions specifically aimed at returning to Venus, named Da Vinci and Veritas. These aren't reckless attempts to repeat past failures. They're carefully engineered efforts to answer questions that have haunted planetary scientists for decades. Did Venus actually have oceans once, the way early astronomers speculated centuries ago? When exactly did the runaway greenhouse effect begin its transformation? And perhaps the most haunting question of all, how did two planets, born from nearly identical conditions, end up with such dramatically different destinies? That question sits at the emotional core of everything we're exploring here. Scientists are actively investigating whether ancient Venus may have once held liquid water on its surface before some catastrophic climate shift sent the entire planet spiraling into the furnace we see today. This remains an active area of scientific research, not a settled conclusion. Nobody can say with certainty exactly what Venus looked like billions of years ago, or precisely what triggered its transformation. But consider what that possibility actually implies. If Venus once resembled early Earth, even loosely, even imperfectly, then Venus isn't just a hostile planet sitting nearby in space. It might be a preview, a demonstration of what can happen to an Earth-like world, given enough time and the wrong set of circumstances. That's what makes Venus genuinely unsettling, far beyond its heat and pressure and acid. It may represent a version of the future that similar planets anywhere in the universe could potentially share. Here's where the story takes one more unexpected turn. The surface of Venus is effectively uninhabitable by any definition we currently understand. But rise higher, somewhere between 50 and 60 kilometers above that crushing ground, and the environment changes dramatically. Temperatures in that upper cloud layer become far milder, closer to conditions we'd recognize as survivable. Atmospheric pressure at that altitude begins to resemble something closer to what we experience here on Earth's surface. That discovery led some scientists to propose something extraordinary, though it's essential to be precise about exactly what has and hasn't been established. Researchers have suggested this cloud layer might be worth studying for unusual chemical signatures, and have speculated, cautiously, about the theoretical possibility of microbial life existing within it. This remains firmly in the territory of hypothesis. It is not evidence of life. No mission has confirmed anything living in Venus's atmosphere. But the fact that scientists take the question seriously enough to study it tells you something remarkable about how strange and layered this planet actually is. A world with a surface that melts lead somehow has, floating far above it, one small band of atmosphere gentle enough to make researchers wonder. So could humans eventually solve this? Could enough engineering, enough determination, eventually let us live somewhere on Venus? Here's the honest answer. Even if we found a way to survive the crushing pressure, the heat would remain. Solve the heat, and the corrosive atmosphere would remain. Neutralize the immediate corrosion, and the deeper challenge of sustaining that protection for months or years, not minutes, would still remain entirely unsolved. Every single obstacle on Venus doesn't operate in isolation, waiting patiently for humanity to defeat it one at a time. They compound each other relentlessly, simultaneously, from every direction at once. The real challenge was never simply landing on Venus. Multiple missions have already proven that landing itself is achievable, however briefly. The real, unsolved challenge is staying alive once you're there, not for a few determined minutes while a spacecraft fights against inevitable failure, but for the kind of sustained, long-term survival that turning any world into a home would actually require. And that brings us to the quiet, uncomfortable comparison sitting underneath this entire story. Mars gets most of humanity's attention when we talk about becoming an interplanetary species. It's the planet of dreams. The destination researchers, engineers, and entire space agencies are actively working to make a genuine future for human life beyond Earth. Venus occupies a very different role in our imagination. Venus is where humanity learns humility. Two planets, formed from strikingly similar beginnings, around the same star, from the same cosmic neighborhood of dust and rock, nearly matched in size, nearly matched in gravity, and yet their paths diverged so completely that one became our home, teeming with oceans and forests and eventually curious minds looking up at the stars, while the other became a world where lead melts on the ground and nothing built by human hands has ever survived for more than a couple of hours. Venus isn't terrifying simply because it's dangerous. Plenty of places in our solar system are dangerous in ways that don't unsettle us quite as deeply. Venus is terrifying because of how familiar it once might have been. Because somewhere in its ancient past, it may have looked enough like our own world to make you wonder how close Earth itself might have come to a similar fate, and what conditions, however small, ultimately separated one planet's destiny from the others. The deeper scientists explore Venus, the less it feels like a distant curiosity, and the more it feels like a warning written across an entire planet, one we're still learning to read. Every mission we send there teaches us not just about Venus, but about the fragile, specific conditions that allowed a planet like Earth to turn out the way it did instead. Somewhere out there, orbiting the same star we do, sits a world that may have once dreamed the same dream Earth eventually lived. A world with oceans, perhaps. A world with a survivable sky, perhaps. A world that, through some combination of forces we're still working to fully understand, tipped irreversibly toward heat, toward pressure, toward an atmosphere that traps everything and releases nothing. We look at Venus today and see hostility, but underneath that hostility is a story about fragility, about how delicately balanced the conditions for a living world actually are, and about how easily those conditions can slip away, even for a planet that started out looking so much like home. If this journey into one of the solar system's most extreme and misunderstood worlds fascinated you, subscribe to Beyond Cosmos, because every week we travel further into the strangest, most unforgettable mysteries our universe has to offer. Thanks for exploring with us, and we'll see you in the next one.